For our entire history, humanity has operated on one baseline assumption: space and time are the absolute bedrock of reality, the unchangeable stage on which everything happens. To test the exact limits of that reality, we spent decades building massive infrastructure, like the 17-mile tunnel of the Large Hadron Collider in Switzerland, specifically to smash protons together at nearly the speed of light. When those subatomic particles collide, they shatter into chaotic debris, trillions of microscopic fragments scattering outward in every direction. To make sense of that wreckage, theoretical physicists attempt to map the paths of the particles. They do this by applying our intuitive rules of physics, assuming that all objects must travel through localized physical space over a strict chronology of time. But building $5 billion physical shovels to dig through subatomic debris relies on a brute force approach. We are studying the messy aftermath of a collision, rather than the underlying code governing it. For decades, the best tool we had to decode that underlying math was the Feynman diagram. These are literal drawings used to track every chronological path a particle could take through space. Calculating a simple collision, say 2 gluons turning into 4, requires drawing hundreds of these diagrams and grinding through thousands of pages of dense algebraic equations. Shrinking the scale to look closer creates a physical paradox. This graph shows the relationship between measurement scale and energy. Moving along the x-axis to observe smaller subatomic spaces requires skyrocketing amounts of energy. Since energy is mass, pumping extreme energy into a microscopic point creates a density that collapses into a black hole. Because our math becomes impossible and our attempts to measure the smallest scales literally delete the space we are trying to observe, the universe is signaling that spacetime is the wrong framework. Faced with these impossible calculations, a team led by theoretical physicist Nima Arkani at the Institute for Advanced Study started working backward from the final results of particle collisions. They noticed a distinct, recurring pattern. After slogging through thousands of pages of algebra, the equations would cancel out until only a single, elegant number remained. The math was only difficult because physicists were forcing the particles to obey the rules of localized space and time. The particles weren't actually moving through a chronological space at all. By stripping away the concept of spacetime, they discovered the amplihedron. It is a timeless, higher-dimensional geometric object that exists purely in an abstract mathematical realm, completely outside of physical space. Instead of tracking individual particles moving step by step through a tunnel, physicists can now calculate the geometric volume of this single complex joule. That volume provides the exact answer to the particle collision. We built an underground machine spanning 17 miles to study subatomic wreckage, only to discover we were watching the three-dimensional shadows cast by a deeper, higher-dimensional geometry. If space-time isn't the bedrock of reality, cognitive scientists argue it operates as a biological user interface. Think of a computer desktop. A blue folder icon on your screen isn't the reality of the machine. It exists to hide the millions of shifting electrical voltages on the silicon chip. Evolution designed space and time as our blue folder, simplifying a complex reality so human brains can navigate it and survive. Because our primate biology evolved entirely within this desktop interface, we are intrinsically biased to think in terms of physical distance and chronological events. We cannot organically map higher-dimensional geometry in our heads. Artificial intelligence operates without biological bias. It doesn't care about the story of a particle traveling through space. It excels at pure pattern recognition and computational efficiency. Advanced AI models are now digesting raw collision data and iterating through millions of geometric permutations a second. They are working backward to uncover the mathematical shapes hidden beneath the data. AI acts as a code reader for this timeless architecture, navigating and identifying patterns in a realm we cannot biologically perceive. The significance of this geometric shift is best understood by looking back at the discovery of nuclear fission and the development of the atomic bomb. Splitting the atom was an in-game hack. We found a way to release massive energy, but we still played by the chronological rules of physical space. We mined uranium, moved it through space, and timed an explosion down to the microsecond. Mastering the math outside of spacetime is a different kind of power, because it targets the framework that makes space possible. If distance is just a mathematical coordinate and time is just a structural rendering, manipulating that deeper mathematical language would allow us to dictate how matter and energy are generated in the first place. A century ago, we hacked our user interface to build a world-ending weapon. Today, we are slowly prying open the developer console of the universe.